very much. So again, Jonathan Jenkins here to talk to you about securing the Windows-based software supply chains. Next slide, please. All right, good to go. So we know what the basic problem is that going on right now, little malware and the whole ransomware bit, but there's a little bit more to the malware, right? Malware could come about because of age, ill intent, open source. Do I really trust it? Kind of like what JC was saying. Malware may be unintentional. So we know that could be an issue. We know as things age, they may not meet the new security minimums that have gone up there, right? Another problem sometimes is you'll have custom development like we have through all the federal agencies, a lot of custom software there. What is happening in those DLLs, in those executables? We really may not know, but over time, can we start identifying what are some things in there that are going wrong? We also have an issue in a lot of agencies where, like DHS, they'll have code and they'll have actual binaries, but no code. What do you do in this case? Is there a way that actually can start mining these executables in whatever form, try to understand how it's built, and from within there, can you try to see, hey, is this something that has some type of malware in there? Is there some kind of weakness in there because it hasn't been upgraded? So our business problem that we're going to talk about today is all about mining Windows-based binaries in whatever language is out there, and specifically related to the EO. As you see there, there's three sections within there. This will provide the centralization of data because we envision grabbing this data and make it readily available throughout a whole ecosystem, the ecosystem being third-party suppliers, governments, or anybody like that. It also could tie into applications like JC has. If you want to build SBOMs from it, here's some extra data of the stuff that we mine in here. And of course, the real big one is the detection. If I can detect very early instead of waiting those 12 to 18 months, imagine if I can see new stuff every time our software runs. Literally, if it's 4 hours, great. If it's 8 hours, great. At least you're getting ahead of it. Okay, next slide, please. Okay. Technical challenges. Again, we quite often look at the software supply chains of what makes it up. Here's my executables. Here's my DLLs. Here's my PEs. Here's my things. But then what are all those binaries within there? What makes that up? Think about the pizza, right? I have sauce. I may have a meat in there. I may have the cheese. Well, what's in the sauce, and where did that come from? And can I trace that all the way back? And so the big challenge is really what's inside there. Can I find the undetectable malware, for example, SolarWinds, which we'll show in a second, flawed libraries, and known libraries? What I mean by known libraries, wouldn't it be nice with all the Windows development that's been occurring for the last 20, 25 years out there, we know what was good, what's flawed, what we can trust, what we can't trust. And then whatever applications we're building, whether it's SBOMs, an application, or whatever, or risk posture, we can go back to a single source and say, good, bad, or unknown. Now, as an example, if we actually had a baseline review of everything for SolarWinds, we would have actually taken a hash of all of the binaries within there. Okay. And then when the new binary came in there that was unexpected, we would have been able to tell the difference. We may not have known what it is, but we would have seen the change if this application was running. And again, the application that we're looking at, Iron Pipeline, could run every 4 hours, once a day, whatever it is on any devices. So consider this an opportunity of something that's already, inside your perimeter. You think it's good, something happens, we'll be able to detect a change. The other cool thing is a lot of times when you uninstall applications or update them, there's actually residual binaries laying around there. Wouldn't you want to know that? Why is this binary still out there? Is it just a mistake? Okay, maybe get rid of it. Was it a threat? Don't know. And of course, with the whole zero trust mentality, we would consider it a threat. Next slide, please. Okay, very simple, big data solution using event handling. Essentially, our software will be able to mine an executable and then walk the list of everything it's built from, stream it up into the cloud. Once it's in the cloud, captured in its raw format, and then we put it into what we say a curated one that's a little bit cleaned up. Classic example is cleaning up the company names. Instead of Microsoft, it could be MSFT. So clean it up so we can actually have it more data ready for further AI or ML analysis. And then we'll also have another data store, which would be what we call the gold. And that is essentially, this is what we can report from. And then finally, we just serve up the data. So we mine it, move it to the cloud. You have the 3 different data sets, if you will, that you can start doing AI, ML, any type of leading or lagging indicators on there. And then with an open microservice architecture, serve it up. Next slide, please. Okay. It's a little bit about us. I do have a big background. It's not so much on the cybersecurity side, but Windows development. I've been Windows development since basically since it started taking off there. And one of my fellows down there, Joe Booth, too. He's written, I think it's like 12 or 13 books, very heavy in .NET. Todd Boss, you'll see on there too. Data architect, been involved with all sorts of cloud platforms, also for 25, 30 years. We know this stuff quite well. Okay, so we have the right team in place. We started a proof of concept back in January when a DHS proposal came out, as you see there on the right there, looking for the same kind of things. Hey, I got a binary executable. I don't know what's in there. Please tell us. So we got that and we said, oh my God, whether we win this or not, this just makes sense. This is an absolute cybersecurity gap. We met Jason, started talking, and then Jason did some verification on his side. And then we said, oh yeah, this is not there yet in the community. Let's go forward. So still building it out. We expect it to be at the tier level 4 level by the end of July, by the end of September, up to 5. And so far, it's just been funded internally. So the technical requirements there, again, we just need to put it on relevant devices. We need some service accounts, basic connectivity, and a web browser. Very lightweight for the customers to put in here, not much at all. And you see the benefits on the right-hand side. Reduce the risk. You're going to reduce the time quite a bit in there. You're going to definitely increase the compliance, the cost. Imagine if this is hunting, kind of like JC noted, that you're not doing the audits. Let the software do it. Let us predict as much as possible so we can actually cut that cost down and also remove the biasness, right? Let's start figuring that out. Next slide, please. Okay, so where we're at to date, we basically laid down all of our architecture. We're spinning up everything in the cloud. We know our approaches on how to handle everything. We have at the coding level right now for the agents, as well as moving the data from what we're calling Event Hub within Azure and moving to those different data buckets. So a lot in progress there. The other key point is making sure it's FedRAMP. That we know that this application would have to be used on premises. For example, companies like Lockheed Martin, no matter what, they want everything. They don't trust Microsoft Cloud. They'll have their own instance. So we need to be able to handle that as well. Can we handle it at all the different levels within the government Azure space as well? Okay. And then after that, we're just going to then start reporting everything out. We also are looking at automatic risk identification. We actually have a patent that can identify waste, risk, and opportunities according to how people engineer. When we looked at this particular solution, fits right into that. So we actually see an ability to use current patent capability on that. Next slide, please. Okay.